Hi viewers, this is Jeyapradha from Department of Computer Applications, SFR College. Today I am going to discuss about wireless communications of computer networks. Let's see the learning objectives of wireless transmission. First you can understand the concept of wireless transmission, then you can categorize the waves and methods to implement spectrum. Finally, you can able to analyze the types of wireless transmissions. Okay, let's go to the topic, wireless transmission. Nowadays, people need to be online all the time. They need to get their hits of data for their laptops, notebooks, smartwatches, etc. For this, we need to do wireless transmission. Wireless data transmission is also called as unguided transmission or unbounded transmission. Wireless communication involves no physical link between devices. Wireless signals are spread over in air, which are received and interpreted by antennas. Now we have one doubt, how antennas are working? Yes, antenna is attached to the electrical circuit of computers or wireless devices, then converts the digital data into wireless signals and spread it all over within its frequency range. Finally, the receptor on other end receives signals and then convert them back to digital data. This is the working of antennas. Next one is the important one, electromagnetic spectrum. Let's start the concepts behind the wireless transmission. First of all, I talk about electromagnetic spectrum. We all know that the sun is our planet's principal source of energy, isn't it? Yeah, its energy travels in the form of electromagnetic radiations. The electromagnetic waves are a type of energy transfer that occur in space, which was first predicted by James Clerk Maxwell in 1865. So, the electromagnetic spectrum is a collection of frequencies, wavelengths and photoelectrons, that means spread of light. Electromagnetic waves spanning from 1 Hz to 10 to the power of 25 Hz. When a charged particle oscillates about an location, it is said to be oscillating, which creates an electromagnetic waves of frequency. So, the wavelength can be calculated using the formula lambda equal to C by F. Now, look at the diagram of electromagnetic spectrum, which have many waves for transmission. Let's see one by one. First one is radio waves. In radio waves, the rapid travel of charged particles across the wires can cause these waves. These waves have a frequency range of around 3 kHz to 300 MHz. In the ultra high frequency cellulars, phone employs radio waves to convey voice communications. Next one is that microwaves. Microwaves is a type of electromagnetic radiations that has a frequency of few gigahertz. But microwaves are commonly utilized in aviation purposes, navigation purposes due to their short wavelengths. Next one is an infrared rays. Infrared waves are produced by hot bodies or molecules. So, the infrared waves are referred to as heat waves. Infrared waves are near the low frequency or long wavelength end of the visible light spectrum. So, next one is an visible rays. Visible rays are electromagnetic waves that can be seen with your naked eye. They can have a frequency range of 400 nanometers to 700 nanometers. Next one is an ultraviolet rays. You know the sun is the primary source of ultraviolet radiation on earth, but the ozone layer absorbs the majority of UV energy before it reaches the atmosphere. So, the UV radiation has a wavelength of 400 nanometers to 1 nanometer. Next one is an X-rays. By blasting a metal target with high energy electrons, the X-rays are actually produced. So, the wavelength range of X-ray radiation is 1 nanometer to 10 to the power of minus 3 nanometers. The last one is an gamma rays. The universe is the largest gamma rays generator. So, these rays are higher frequency region of electromagnetic spectrum, which have a wavelength range of 10 to the power of minus 12 meter to 10 to the power of minus 14 meter. Okay, from all of these waves, UV rays, X-rays and gamma rays are not used for transmission due to their high frequencies and also it can be dangerous for living beings. Okay, think what can we do with the spectrum? Due to the increasing demand for wireless communications as limited spectrum efficiency problem, isn't it? So, to solve this, we have used spectrum communications. Therefore, a collective class of signaling techniques are employed before transmitting a signal to provide a secure communication is called spectrum. There are two principles have been followed by spectrum process. First principle is to allow redundancy because it is necessary that bandwidth allocated to each station should be larger than needed. So, it must allow redundancy. Second principle is the spread process occurs after the signal is created by the source. So, using these principles, three different variants of techniques have implemented for spectrums. They are frequency hopping spectrum, direct sequence spectrum, ultra wideband communications. Okay, first one, frequency hopping spectrum. In this technique, the transmitter hops from frequency to frequency hundreds of times per second. So, it is popular for military communications because transmission hard to detect and also impossible for jamming. It also offers good resistance to multipath fading and narrowband interference because the receiver will not be stuck on an impaired frequency for shutdowning communications. Next technique is an direct sequence spectrum. Direct sequence spectrum uses a code sequence to spread the data signals over a wider frequency band. These signals have used CDMA methods like code division multiple access method for generating different codes. It also forms the basis of 3G mobile networks like GPS in mobile phones. Without different codes, direct sequence spectrum is also acts like a frequency hopping spectrum which can also tolerate narrow bandwidth interference because only a fraction of the desired signal is lost. Okay, the final technique for spectrum is ultra wideband communication. So, ultra wideband communication sends a series and rapid pulses with varying their positions to communicate the information. This rapid transition lead to a signals that is spread thinly over a wide frequency band. This ultra wide band has very little energy at given frequency when used for short range transmission. So, it does not cause any harmful interference to those other than narrow band radio signals. This feature then leads to you set the underlay the other signals in UVW. Now look at the diagram which categorizes the types of wireless transmission. They are radio transmission, microwave transmission, infrared transmission and light transmission. Let us see one by one. First one is radio transmission. In radio transmissions, the radio frequency waves are easy to generate because it can travel long distances and also it can penetrate buildings easily. So, they are widely used for communications in both indoors and outdoors. Also, radio waves are omnidirectional, so they travel in all directions from the sources. One of the property of radio waves are frequency dependent. For that, at low frequencies, radio waves passes through obstacles well, but the power falls off with the distance from the source in air, so the signal energy is spread more thinly over a larger surface. This attention is called path loss. For high frequencies, the radio waves tend to travel in straight lines and bounce off obstacles. Radio waves then continue to their frequency ranges. Radio waves of high frequencies are prone to be absorbed by rain and other obstacles. So, they use ionosphere of earth atmosphere to tolerate the problem. When they reach the ionosphere, they can refract it back to the earth again. Next one is an microwave transmission. Electromagnetic waves tend to travel in a straight line and the signals over them can be sent by beaming those waves towards on one particular station. This microwave travels in straight lines. Both the sender and receiver must be aligned to be strictly in line of sight. Even though the beam may be well focused at the transmitter, there is still some diversion space. The delayed waves may arrive out of phase with a direct wave and then cancel the signal. This effect is known as multipath fading. Microwave antennas concentrate the waves, making a beam of it which can be aligned to reach further. Microwave have high frequencies and do not penetrate wall-like obstacles. It highly depends upon the weather conditions and the frequency ranges. So next one is infrared transmission. Infrared waves lies in between visible light spectrum and microwaves. It has a wavelength of 700 nanometers to 1 nanometer and frequency ranges from 300 GHz to 430 terahertz. It is used for very short range communication purposes, for example, television and its remote. Infrared travels in a straight line, so it is directional by nature. Because of high frequency range, infrared cannot cross wall-like obstacles. So, no government license is needed to operate in infrared systems in contrast to radio system, which must be licensed for ISBM bands. Okay, last one is an light transmission. So, highest electromagnetic spectrum which can be used for data transmission is light or optical signaling. This can be achieved by laser, which tends to travel strictly in straight line. Laser transmission is actually unidirectional one. For that, both ends of communication can be needed to implement. For example, the laser and the photo detector needs to be installed on both sides of the communication. Laser beam is generally 1 millimeter wide. How it is a work of precision to align two for receptors, each pointing to laser sources. Look from the diagram, we observe that laser works as transmitter and photo detector works as receiver. Laser cannot penetrate obstacles such as walls, rains or fogs. Also, laser beam is distorted by wind, atmospheric temperature or variations in temperature in the path. So, laser is safe for data transmission as it is very difficult to tap 1 millimeter wide layer without interrupting the communication channel. Okay, as a conclusion, to conclude that wireless communications are globally expected as technology advances. So, wireless communication has a lot of benefits and can make the world a lot more efficient. It does not have concerns thrown with every other and new advancement that is made in today's world. Thank you viewers. Let's see in another video.